Yeah, next is increment and decrement operators, and actually plus plus minus minus are called as increment and decrement operators. Plus plus is increment operator and minus minus is decrement operator. The important thing is after you give plus, there should not be any gap. There should not be no gap. Then only it is increment and decrement operator. So the increment and decrement operators are further divided into two. One is pre-increment decrement and post-increment decrement. So when you take, there one more thing to note about this is that both are unary operators. That means they are applied on one operand. So an operator is called as unary when it is applied on one operand, binary when it is applied on two operands. If you take all arithmetic operators, whatever we have seen, they are binary operators. Whereas the increment and decrement operators, they are unary operators. They are applied on one operand. Now, suppose if I take A as operand, and if I use this operator before it, it is pre-increment. Suppose if I use that operator after it, it is post-increment or decrement. So this is pre-increment or increment operator. This is post. So if you use this increment decrement operator before the operand, then it is pre. When the operator is used after the operand, then it is post. So what is the difference we are going to see? Before we see the difference, what actually this increment decrement does is it will increment or decrement the operand by 1. That is going to happen surely. So the increment and decrement operators are going to increment and decrement the operand by 1. So the increment, decrement the operand by 1. This is the common thing, what it does. And now when I take the post and pre and post increment, suppose if I take A equals to 10, now whether I say plus plus A or A plus plus, there is no difference as far as the operand on which it is applied. So if I use A equals to 10, after this, A is going to become 11. Here also, suppose if I use A plus plus in place of plus plus A, then A is going to become 11. So when I use this operator with just that particular operand and that expression is not part of any other expression, the operand will be incremented in both cases. There is no difference. So only when, suppose if I take this, suppose if I take B equals to plus plus A, if I am involving in some other expression, I am using assignment operation, which is another expression in addition to the increment. Now, if I say B equals to A plus plus, then there is a difference. So, but as far as the operand on which this increment and decrement operators are applied is concerned, there is no difference in both cases, whether you use it in the expression or you use it alone, the operand is going to be incremented by 1. But if you use it in expression, now when it is plus plus, when it is plus plus A, it is incremented first. So pre means do it first. Pre here, just interpret in this way, do it first before you use it. Do this increment or do first, do increment or decrement first before you use it, or using it. Post means first use it before that means here when I take this is pre. So do this first. So A, suppose A is 10. Now assume that B is some value, whatever it is, it does not matter. Suppose assume that it is 25. When I say plus plus A, first increment, because pre, do it first, then use it. Now I'm going to use A. A is assigned to B, so it is going to become 11. Now in this case, when I take this, first use it because it is post, means you increment afterwards, but first use it. So A is 10 here. A is 10. A is 10. So I have to use A first before I increment. So in this case, B is becoming 11. In this case, B is becoming 10. So the difference is there when that increment and decrement expression is used as part of some other expression, especially in assignment. So in case of first, it is going to be done. That is increment or decrement is operation is going to be performed first before it is used. So that is the increment and decrement. Suppose if I take this alone, this operator alone, because it is not involved in any assignment, so it is there is no difference between the two. But if it is used in some other part of expression, some other expression, then it is going to be the difference is if it is pre, first do that increment decrement, then use it. If it is post, first use it, then increment and decrement. That is increment decrement operation. Now one important thing to note here is, suppose if I take character uh, a equals to, suppose I give 127. Now if I say a plus plus, what do you get? What is the result of this? A plus plus. So when I say 127 character, and if I give a plus plus, what is the value of this? Is 127. It has to become, what is its value? A value. So here 128, but it will not be 128. It will be minus 128. Is actually, you have to be aware of the range of numbers. So when you take the range of numbers, character is signed, and the range is minus 128 to plus 127. If I say 127 plus 1, it is beyond the range. And when you take beyond the range, it is actually, you can interpret the numbers like this. It is better for understanding. So what I'll do is I'll take suppose 3-bit number or 4-bit number. The range is minus 8 to plus 7. So the 0 will be here, then 1, 2, then minus 1 this side, minus 2 this side, minus 3, minus 4, minus 7, minus 8, 3, 4, 5, 6, 7. So this is how it is. So when I increment 7, because the number, if you interpret like this, after 7, what you will get? Minus 8. So after maximum, positive maximum, you will be reaching negative maximum, because when you take binary number system, suppose if I take minus 7 is 0, 1, 1, 1. If I add 1 to it, it is 1, 0, 0, because the next number is 1, 0, 0. If you take this is 2's complement system, this is minus 8. So uh, to understand this, you can represent a cycle like this. So it is 0, 1, 2, 3, 4, 5, 6, 7. That is positive maximum. Then minus 1, minus 2, minus 3, and negative maximum. So if I try to increment 7, I'll get minus 8. Now if I try to decrement, suppose if I subtract minus 1 from this, I'll get 7. So that is how the process goes on. That's how it goes on. So same thing if I use here, because 127 is the maximum positive number for character range is minus 128 to plus 127, because it is 8 bits. So after positive maximum, if you try to increment, you will get a negative maximum. So result of this is not 128, it is minus 128. You should be very careful. So that's why I told you, you must be aware of the range of the data item which you are using. So when you are not aware, and if you are involving that in some arithmetic operations, and if the result goes beyond, if the result of that expression is goes beyond the range, then you'll get wrong results, and you will not be, it is not easy to identify the wrong results. In this simple kind of things, it's very difficult to identify the wrong results. You must be aware of the range. Even if I take, for example, suppose if I take A equals to 120. Now, if I say character A equals to 120, now if I say A equals to A plus 10, A equals to A plus 10, then what do you get? You will get, so if I take, it is 127, 126, 125 minus 128 minus 120, minus 9 minus 130, is not minus 1. Minus 127, minus 126, and so on. So if I take 120 plus 10, it is 130. So when I take 130, so 130 means 127, 128, 129, 130. So 130, if I use here, it is minus 126. This will produce A after, because it is 130 here, 127. If I add 1, I'll get minus 128. Add 2, minus 127. Add 3, minus 126. So because it is, I'm adding 10. So if I add 10, I'll reach minus 126. So this is result of this operation minus 126. But to be very careful, it looks simple. So we should not, even if some expression, something looks simple, you should not just directly jump to a conclusion about the result. You have to consider ranges, then you have to decide the result. A very important thing to note related with ranges. So that's about increment and decrement operators. So increment, decrement operators are actually um, uh, by unary operators, and they are applied. So they are applied on one operand, and they will increment, decrement the operand by one. And as long as that increment, decrement expression is alone, there is no difference. Once it is used in some other assignment operation, then there is a difference. If I use pre first, it has to be incremented or decremented, then used. Then if it is post, first we have to use it, then incremented and decremented. So that is how we work with. So that's about increment, decrement operators. We have seen next set. Fourth set of operators is relational operators. Relational operators. So when you take the relational operators, they are used to compare the magnitudes of two operands. So the different relational operators are like all what we use in our day-to-day life: greater than, less than, greater than or equals to, less than. And not equals to, we have to use like this: exclamation equals to, this is not equals to. And if I want to check whether two are equal or not, I have to use double equals to. This is less than operator, and greater than operator. This is less than operator, greater than or equals to, less than or equals to, then not equals to. So this is normally we use not equals to in our day-to-day life in mathematics like this, but in there is no such symbol on keyboard. So you have to you can get that effect with the two symbols like exclamation and equals to. This is not equals to. And single equals to we are already using for assignment, so I cannot use it for comparison. So if I want to compare whether A equals to B or not, I have to use A double equals to B. If I use A equals to B, it will not compare, simply B value is assigned to A, because simple equals to will assign the value, so it is assignment operator. Double equals to is equals to operator. This is so these two are different compared to our day-to-day. Is are different. our because generally we use not equals to like this and equals to with same single. Not only in C, in any language we don't use this. Maybe some languages, but most of the recent languages like Java, Python, C, we use double equals to for comparison. With not equals to for exclamation and equals to for not equals to operation. The relational operators. One, when you take the syntax of the relational operator, so operand one, they're all binary operators. Operand one, the symbol, operand. The result of this expression is 1 or 0 because it will compare, it checks whether it is true or 1. 1 is true and 0 is false. But as I already told you, true is not just 1. It is not just 1. So that the result of the expression is 1, 1 is true. But true is not just 1. Any non-zero value, but any non-zero value is true. But false is always 0. So this also you have to keep in mind when you deal with the expressions in C, because C behaves differently compared to the other languages. So the syntax of relational operation is operand 1 and operator and operand 2, and the result is always 1 or 0. And 1, if you get 1, it is true, and if you get 0, it is false. Now, for example, suppose if I take A is 10 and B is 5. Suppose if I say A greater than B, so this will give the result as 1 because it is true. Suppose if I say A less than or equals to B, it gives as false, 0. Now suppose if I say A double equals to B, it will give the result as 0 because it is false. Now if I write A equals to B instead of this is it will not give any kind of error. So A is 10 and B is 5. So I am using as this as relational expression. So what is going to happen is now B is going to be assigned to this, and the result of this expression is 5. 5 is considered to be true. So this is how it works. So by mistake, suppose instead of using double equals to, suppose if you are using, the result will change. So this is A double equals to B is 0, but here A single equals to B, it is not only changing A value, but the result instead of false, now it has become true. So you have to be careful when you are using equals to operation for comparing two numbers, whether they are same or not. By mistake, if you use single equals to in place of double equals to, the result will be changed. And as I told you, this kind of mistakes, it is very difficult to find because C will not help you to find them. It will simply execute result, and the result is wrong or right, we may not be knowing always. So it is very difficult to find this kind of mistakes. So while using, you have to be careful. If you want to compare two numbers, whether they are same or not, you must go for double equals to. By chance, if you are going for this, it is going to be a problem because no error. So this is the relational operators, and relational operators are always uh, generating the Boolean value. Boolean value 1 or 0. 1 indicates true, and whereas true, if you take, not just 1 is true, but any value other than 0 is true. So that's why it is called as non-zero value. Any value other than 0, which we call it as non-zero, that is the relational operator. Uh, Next, that is the fourth kind of operators. Next is logical operators. Now, when you take the logical operators, generally we use these logical operators to combine two or more relational expressions. To combine two or more relational expressions. So we want to combine multiple relational expressions which we have built, like there is A greater than B, and also check whether B is greater than C, something like this. I want to combine these two logical operators. So logical operators are used to combine two or more relational expressions, and there are actually three kinds of operators. One is ampersand symbol. This is called as ampersand. So you have to use two ampersand symbols without any gap. That is important. This is called as logical and. If you use single ampersand, the meaning changes. If you take this pipe symbol, this is called as pipe symbol, two pipe symbols, it is there on the keyboard above enter actually. So this is logical OR. Now, when I take, there is not, this is logical not. If I use logical not, this is unary operator. This is these are binary operators. These two are binary operators. So another difference between unary and binary is because binary is dealing with more than one operand or one expression, it should be used in between the two operands or expressions. But unary is always applied on single, so it will be in the beginning of that operator or expression. So this is logical and logical or and logical not. Now we'll see individually each one. So first, if you take the logical and, so logical and, you pronounce it as and, not and. Logical and, this is two ampersand symbols we have to use. So when I take this expression 1 and expression 2, then the result of expression 1 ampersand expression. So when I take expression 1 as false, expression 2 as false, the result is false. Expression 1 is false, expression 2 is false, the result is false. So expression 1 is true, expression 2 is false, the result is false. Only when both are true, the result is going to be true. So this is logical and. So if you use logical and on two expressions, then result of the expression will be true only when both are true. If at least one of them is false, the result is going to be false. So that is the logical and operation. Now, for example, if I take here, so A is 10, B is 5, C is 20, D is 15. Take A greater than B, I'm taking one expression, combining with another expression C less than D. Suppose if I use this than D, is another expression. Now first A expression 1 is A greater than B. A greater than B is true. So if I use A greater than B, this is true, and this is false. So first one is true, second one is false. Then the result of the compound expression is false. So first expression 1 is evaluated true, then expression 2 is evaluated false, then the result of the compound expression is false. So this is one thing to note, but one very important thing to note is here whenever expression 1 is false. So when expression 1 is false, whatever may be the result of the expression 2. So when expression 1 is false, whether expression 2 is false or true, the result is going to be false. So because this is actually this is how it because both should be true to make the compound expression true. When expression 1 is false, what computer does is it will not check expression 2. It will not bother about evaluation of expression 2 because whatever may be the result, the result of expression 2, the result of the compound expression is going to be false. So this is a very important thing, because based on this, there will be some results sometimes in some placement exams. This kind of questions will be given. Remember that when expression 1 is false, expression 2 is not going to be evaluated at all, because irrespective of its result, the result of the compound expression is going to be false. Expression 2 is going to be evaluated only when expression 1 is true. Very, very important point to note. So suppose if I take here, now if I take A greater than, suppose A less than B, I'm giving. Now I want to compare C whether equals, whether it is equals to D or not. I'm writing like this instead of double equals to, I'm giving single equals to. Now, in this case, normally C is assigned with D, but here A is less than B is false. So A is less than B is false. So because A is less than B is false, this is not going to be evaluated at all. So C remains 20 and D remains. Suppose if A is, if I use some A greater than B, then and what is going to happen here? This is going to be true now. This is going to be true. Now, when this is true, then this is going to be evaluated. When it is evaluated, so what is here? Uh, 15 is assigned to C, and the result of this is 15. 15 is true. Both are true. The result of this expression is true, and C is also going to be changed to 15. This is very carefully, this is kind of expressions are very common, and you have to carefully evaluate it. This is actually called as shorthand short circuit operation. This is called as short. When expression 1 is false, it will not bother about expression 2. It becomes short circuit. If you are electrical or electronics, you may be knowing for a short circuit. So it will bypass the path and it will go in short path. So short path is skipping expression 2 here, then generating the total result. This is called as short circuit operation, because expression 2 is skipped. Only expression 1 is evaluated when expression 1 is false. So this is logical AND operation. So similarly, when I take logical OR operation, logical OR is done with pipe symbols. So take this pipe. This is logical OR. And when you take this logical OR, there is expression 1, expression 2, expression 1, expression. So when I take this, this is false, false, the result is false. False, true, the result is true. 1 is true, expression 2 is false, the result is true. Expression 1 is true, expression 2 is true. So only when both the expressions are false, the result is going to be false. Otherwise, the result is going to be true. That is OR operation. When both the expressions are false, the ORing will give you false. Otherwise, the ORing will give you true. And again here, this short circuit thing here is, again, there is a short circuit possibility here. So if expression 1 is true, so irrespective of the, if expression 1 is true, irrespective of irrespective of expression 2, the result is going to be true. So expression 2 is not evaluated. In case of AND operation, when first expression is false, the second is not going to be evaluated. In case of OR operation, if the first expression is true, second expression is not going to be evaluated. Only when the first expression is false, now the results depend upon second expression. So the second expression, this is again same as the AND operation. So you have to be careful. So when I take short circuit here, so when I take AND expression 1, expression 2, so when it is false and it is AND, then it is short circuit. Short circuit means this is not going to be evaluated. Short circuit means this is not going to be evaluated. Now, when this is true and it is OR, then it is short circuit. So this is not going to be evaluated. So in case of ANDing, when expression 1 is false, it becomes short circuit. So expression 2 is skipped. In case of ORing, when expression 1 is true, then expression it becomes short circuit. So expression 2 is not going to be. Now, for example, suppose if I take A is 10, B is 5. Suppose if I say A not equals to 0, A not equals to 0, or B greater than. Now A not equals to 0 is true. So this is not evaluated because it is short circuit, and it is going to be true. Next, suppose if I say A equals to 0, then suppose if I write B not equals to A, suppose if I write like this, then this is false, then it will come here, this is true, then the result of the expression is going to be true. So this is how the short circuit operation works with ORing and ANDing. So while you evaluate the expression, don't blindly jump to a conclusion. You have to carefully observe the expression, whether short circuit is happening or not, whether there is assignment or equals to operator is there. Those kind of things you have to carefully observe before you decide the result of the expression. So that is logical handling. And next, in logical operators, the next one is not operator. So this is not operation. The symbol is not, and it is unary operator. Unary operator. So we can apply on single expression or compound expression, but it is applied. Uh, it is actually kept before it is prefixing the operand or expression. So suppose if I can write not A. Suppose A is 10. So what this means is A is not A means whether A is 0 or not. If A is not 0, this is going to be sorry, A is 0, it is going to be true. So this says A is not A means A, suppose if I take A is 10 and 10 is true, not A means it is going to be false. So it checks whether A is 0. If A is 0, it will give true, otherwise it will you can apply on single variable. I can also apply suppose A greater than B. So this is actually what it does is it complements the operation. So not what it does is it complements the result. So suppose if I take expression 1, it may be single expression and not expression. So if this is false, this is going to be true, and this is true. So suppose if I write A as 10 and B as A as 10 and B as 5, A is 10, B is 5, then if I say 10 greater than 5, is true, this result of this is true, not this is going to be false. So similarly here, if I say not A, not A is 10. So A 10 is true. Suppose if I take A, because any value other than 0 is true, this is true. So not A is going to be false because A is not 0, it is going to be false. This is how it is evaluation is made. You can also combine something like A greater than 10, I'm taking this, then I'm using ampersand and B less than 10, if I'm writing like this. Now I can use this not operation, can apply on anything. When I take this A is 10 greater than 10 is false, then this is short circuit, it is not going to be evaluated. So the result of this compound expression is false because now there is a not present, so it is going to be true. This is how the evaluation is made. So not I can apply on single variable, I can apply on single variable, I can apply on single expression, and I can apply on compound expression. So even if I apply on compound expression for not, it is single expression only, because first that full compound expression is going to be evaluated, then the not is going to be applied. So that's why it is unary operator. So it is always prefixed with that expression may be a simple variable, single variable, or it may be a logical expression, or it may be uh, a compound logical expression, or it may be an arithmetic expression also. So in C you can also write like this. Suppose A is 5 and B is minus 5. Now I can say not A plus B. I can also write like this. So A is 5, B is minus 5, A plus B is 0. So this is 0, which is false. If I use not this, it is going to be true. So I can, the expression what I'm keeping, generally it should be a relational or logical expression, but in C it can be any kind of expression because this is because of the definition of true or false values. So arithmetic expression also generates some integer value, some number. So the number other than 0 is true and 0 is false. So if I take not A plus B, so A is 5, B is minus 5, the result is 0. So if I use 0 here, it is going to be true. So this is how so that is about the that's about the uh,